Going on, y'all? Here's a quick video to show y'all what we do on maintenances for furnaces. This is a Goodman gas furnace, gas to American Standard air conditioner. 6 years old, 2014 October. It's the manufacturer's date. And pretty much what I do. The first thing I do is I will turn it on from the thermostat just to make sure I know it's getting the proper signal. And then once I hear the inducer motor engage, I'll kill power, which is the red emergency switch. Those actually do fail, so you want to test those. The reason why I turn it on, make sure I confirm power, and then turn it off, because I do cold readings first. So first thing I do is I will check the resistance on the igniter. This one is a hot surface igniter. It glows kind of like an electric stove. There's a resistance value. You can see on it that there's a small portion that's starting to turn white, which is not necessarily a bad thing. Once the whole metal turns white, that's when you want to think about replacing it. So you can Google it or call the manufacturer, but I know this one has a resistance rating of 40 to 90. So put my meter on resistance. Sorry, my GoPro storage is full, so I'm using my phone. We're at 47, so that's good. And then the inducer motor, some of them have capacitors, some of them don't. This little black square thing is a capacitor, and this one is a 6 microfarad. So we're going to switch this to 6 as a microfarad, and then we're going to test the capacitor. That's pretty much spot on. Yeah, I uploaded all my videos from my GoPro to the computer, but it didn't delete the file, so gotta do it the old-fashioned way. Alright, so got that back together, got this back together. Now, what I do with the flame sensor, I read it before I clean it. So, take this off, switch this to the millivolt DC settings. Yeah, set to the millivolt DC settings. Got one wire here, which goes to the flame sensor. And I put my lead on the flame sensor itself. And my rule of thumb, if it's 2.0 and above, then you're gonna be good. 1 point, anything below 2, I take it out, clean it, put it back in, see what it'll do. Usually goes back up, and then we go from there. So I have the system jumped out. Hose back on. I also have my gas meter connected up. A little manometer. Now just kicking on. Look at that. So that flame switch is good. I'm not even going to take it out, hit it, and clean it because it's good. If you got a dirty flame sensor, this is what it would do. It will kick off. This is the most common service call, at least that I get. So try a couple times before it gives up. But yeah, with a dirty flame sensor, everything will kick on like normal. You'll see the glow, and then the flames will actually fire off, and then it'll stay on for like 2 seconds and kick off. So this is what it'll do. Just like that. So put this back up. And now we're going to check the gas pressure, low stage and high stage. There's a sticker on the back of the gas valve, depending on the way it's set up. It'll tell you what your gas reading should be. Right there in the barcode. This one's 2.0, 3.5. So we're going to see what this one's reading when it fires up. It's not too bad, a little high. So we're going to go ahead and adjust that. See, it's low. Right here. This one's high. I'll take this one off. Adjust it to whatever you need. Close enough. Close enough. This one looks like it's set up just for high stage. So you'll know because we'll hear it shift the gears. Across the entire burner assembly. So it'll start off at the igniter and then it'll flow through these little wings to each burner until it hits the flame sensor and then kick on. So you just want to make sure you don't got any fluctuations in between the flame, and then I tend to let the system run for about 15 minutes just to see if any error codes will appear with the sight glass. And then check the amp draw. To the motor, the Inducer Motor. So we got 4.5. This one should be at 0.40. So it's pulling pretty much half an amp more than what it's designed to, but there's a lot of factors that could be in play. It could be rust, corrosion, anything within the lines of that. So if it was like 1.2 or something like that, then that's different. Then this motor's on its way out, or it has a bad capacitor, one of the two. So you want to check that. And then you want to do the same thing with the blower motor. Just take and draw the blower motor, make sure that's within spec. In these situations where you got a downflow furnace, you'll have a plate covering the blower motor, but you'll have to take these 6 screws off, flat screws, to get to the blower motor, move the exhaust and all that. And then what I normally do is move the capacitor to the outside, because most people won't take this off and check it. This capacitor was recently replaced, so I know it's good, so I ain't gonna do all that. Next thing I do is I always spray the gas line, make sure it's not leaking, because you don't want to keep reusing these. Like if you get a new furnace and these are reused, sometimes it'll leak. But you will know, because you will smell that rotten egg smell. Then you know that's leaking gas. The next thing that you can do, or at least what I do, is you want to take the door off to the coil, because the furnace has to blow past the coil. No matter if you got an upflow or downflow, it has to blow past the coil. You want to make sure the evac coil is clean, so you don't have like overheating and stuff like that. So letting it run for 15 minutes will let you know if it's going to overheat or not. But you always want to take the door off and look at it, which I'm going to do in a second after I let it run for a minute. Alright, so it ran for 15-20 minutes, killed power, took the door off. Here's the cooling coil. You can see the cooling coil is nice and clean, so there's no airflow restrictions. You can also look for oil, make sure you don't have any issues in spraying time. It'll literally just look like baby oil sitting in the pan. When you're ready to put this off, it'll be slick. And then the other thing is you can check the heat exchanger, make sure you don't have any splits or cracks. You can just a couple ways you can figure that out. You can tell just by looking at the flame if you got holes in your heat exchanger, but you do that. And I always take a picture of it so I can have a reference from the year before. This thing glows cherry red in some locations. It's typically the back. And if you rapidly heat and cool metal, it'll split. So that's what happens. That's why we get these things 10 to 15 years. Keeping the filter ran too long, oversized unit, undersized ductwork cause these things to split, crack prematurely. So that's that. And then do a once over. Check your filter, check all your electrical connections, make sure those are tight. You want to check your transformer. This transformer should be fairly cool to the touch. You should be able to keep your hand up there for a steady period of time. If you touch it and it's really hot and you got the urge to do that, or you hear it buzzing, it's trying to change that transformer. And also check voltage to the furnace, amp wise, because a lot of these furnaces have a certain amount of current that it should be pulling when it's operating, and you want to make sure it's within that range. So less than 12 amps, you want to check that, especially during startup and just when it's running. Check that. Make sure the electrical's tight, no leaks on the gas line. Sweep out and clean the burner compartment. You're going to get this rusting right here. Not too much of a cause of alarm until it gets really bad. It just cup on the coaster effect. It's hot in here, cold, probably in the attic or the garage where your furnace is at, so it's going to sweat and then it's going to drip a little bit. So that will eventually rust out the top of this, which can get to your burners, which can prevent the flame proper migration across of it. So you want to check that, and then you're good to go. So just quick test. If you just want to make sure if it's just running, quick test is come. Main thing, check the flame sensor, let it run for a couple minutes. that's pretty much it. Everything works in a sequence. So if one thing doesn't work, the whole furnace is not going to work, and that's when you have a no heat call. So I'll go in depth on the next video on the sequence of operations and how the thing works. So that's pretty much it. Just want to do a quick maintenance video, and see you next time.